So today we are starting our topic of fluid pressure, which is for class 9 students. So before going into the chapter, we will understand some terms related to the chapter. So the first thing we have to understand is thrust. What is this thrust? Thrust is a kind of force which acts perpendicular to the surface of the body. Like suppose you have a stamp and you have to stick on a paper. So the force you apply to stick that stamp is perpendicular to this paper. So the force which you are applying to stick the stamp over a paper is known as thrust. Okay. One more simple example. You are walking on a field. Okay. You are walking on a field. So when you walk, your feet puts a pressure on this field. So this force which is acting on the surface of this field by you, that is also a thrust because it is applying perpendicular to the surface. Okay. So understood what is thrust? Thrust is a force which is applied perpendicular on the surface. The SI unit of thrust is Newton. That is of force also. Newton is a SI unit for force also. And in CGS, the unit is dyne. So this you have to learn. So understood what is thrust? Thrust is a perpendicular force applied on a surface. And its SI unit is Newton. And CGS unit is dyne. Okay. The unit of thrust in terms of gravitational force is also written as kilogram weight or kgf, kilogram force. We also write the unit of thrust in terms of kilogram weight and kilogram force. The relation between 1 kilogram force and Newton is that 1 kilogram force is equals to 9.8 Newton and 1 gram force is equals to 980 dyne. In terms of dyne, you have to write 1 gram force equals to 980 dyne and 1 kilogram force is equal to 9.8 Newton. So this is about our thrust. Now the next term which we learn in this chapter is pressure. What is this pressure? You have learned this term earlier also. Pressure is termed as force acting on per unit area. Any force which is acting on a per unit area is known as pressure, and because of which its formula is equals to pressure equals to force upon area. Understood? You have learned this formula earlier also in terms of force. Now if we want to write it in terms of thrust, then this force will be converted as thrust. So our definition in terms of thrust would be pressure is per unit thrust applied per unit area. And what is thrust? Thrust is perpendicular force applied on a surface. Got it? I hope you have understood till here. Now in this chapter we will use pressure equals to thrust upon area. Thrust is a perpendicular force. This pressure, if we want to know the unit of this pressure, what would be the pressure unit of pressure in terms of CGS system? The unit of thrust in CGS system is dyne, and we know that the unit of area in CGS system is centimeter square. So unit of pressure in CGS system would be dyne per centimeter square, or you can write it like this, dyne centimeter to the power minus 2. Okay. Similarly, if we want to have a unit in SI system for pressure, then it would be Newton per meter square, or you can write it Newton meter to the power minus 2. Why Newton per meter square? Because in SI system the unit for thrust is Newton and area unit is meter square. So till here it is very easy. You had known the definition as well as the units. Now moving forward towards the fluid pressure. What is a fluid? Fluid is any liquid, and in the chapter matter we had already learned the properties of liquid. Okay. Liquid is having some intermolecular spaces in between their molecules, and their molecules are easily movable inside the vessel in which it is filled up. Okay. Because they are vibrating inside the vessel and they are colliding with each other, they are creating some force over the walls of the vessel. Okay. Whichever vessel you will fill the fluid, they will create a kind of pressure on the walls of that vessel, and this pressure will be created because of the collision of molecules of the fluid. They are moving here and there and colliding with each other, and they are also colliding with the surface of the or the wall of the vessel, and they are creating a kind of pressure over the walls as well. Okay. So this pressure is known as fluid pressure. Okay. Similarly, if we take a beaker and we fill up any fluid inside this beaker, this fluid will exert a pressure on the side walls of the vessel, on the base of the vessel. Okay. And because it's a circular kind of, it's a, you can see it's a cylindrical figure, it's a cross sectional area under which the fluid is filled, so it will exert pressure on all the sides of the vessel. Okay. Now what happens when you fill up fluid in a vessel? This side, this surface, the base of the vessel will feel some pressure. Okay. This pressure is due to the weight of this liquid filled in the vessel, and we know that the pressure is equal to force upon area. Okay. And this force which is exerted on the base or the surface of the vessel is due to what? Is due to the weight of the liquid filled in the vessel. What is weight? Weight is equal to mass into acceleration due to gravity, m into g. Okay, and we are saying that the force or the thrust on the base of the vessel is due to weight of the fluid which is filled up in the vessel. Got it? So this force or thrust, this is due to the weight of the fluid, and this weight is equal to mass into acceleration due to gravity, right? Now what is mass? Mass is volume into density. What is mass? Mass is volume into density. Okay, and further if we elaborate this formula, we can write volume as area into height into density. Okay, area into height into density. Now see the formula which we had taken, P equal to F upon A. This F is the weight of the liquid or the fluid, which is equal to mass into gravity, and mass is A into H into D. So we can write in the place of F area into height into density, and what is the formula? F equal to m into g. This is for m, and we have to include gravitational acceleration also, and A means area, so this is the area of cross section of the beaker. Okay, this is the area of the cross section of beaker in which we had filled the liquid. So what will happen? This A will cancel out this. Our formula for pressure, fluid pressure, would be HdG, and in case of fluid pressure we denote our density in terms of rho. H rho g would be the formula for fluid pressure. This rho is the density. Now see, from the formula itself, this fluid pressure is directly proportional to the height of the fluid. Okay, this is the result which we get from this formula or the derivation, that pressure is always directly proportional to the height of the fluid. If you consider a beaker filled with this fluid, this formula indicates if we increase the height of the liquid or the fluid, the pressure will also increase. So if we increase the level of the fluid in the beaker, the pressure exerted on the surface will also increase. And if we decrease the level of fluid, the height of the fluid, then it will exert less pressure. So this P is directly proportional to height, means if we increase the height of the liquid filled in a beaker or any vessel, then the pressure will be more. Next, P is directly proportional to the density of liquid. Okay, if the density of the liquid is more, then the pressure will also be high. What is density? There are some molecules in any matter. So per unit area, if there are whatever the number of molecules is there in per unit area, that is its density. Okay, we say population density of an area. How do you define that? We define where the maximum people are residing in a particular unit of area, then that is known as the density of that area. Okay, you take any area and you just check what density is there, what how many people or how many this molecules are there, that is known as the density. So the number of molecules per unit area is defined as density. So for any fluid which is having high density, the pressure is also high. Got it? Now, third one is pressure is directly proportional to acceleration due to gravity at any place. Okay, if the gravitational force is high, then the pressure is also high. So we are talking about fluid pressure here. So these three things you have to keep in mind, or you have to keep this formula in your mind, and from where this formula has come, we had derived that formula today. Now we will discuss one application which is based on this formula only. Suppose we take a beaker and we make some holes in it, okay, and fill up a liquid inside this beaker. Okay, now what will happen? A, B, C, D, E and F. If we make a hole, water will come out from this hole. Okay, from this hole also water will come out, and from this hole also water will come out. But the way the water will come out are different from different holes. Why is it so? Because as we move upwards, the height of fluid is increasing. Okay, and as we move downwards, the height of the fluid is decreasing. So for this point AB, there are three levels here. As we put hole nearer to the surface, the height of the fluid here is the maximum as compared to AB or CD. So the pressure of water will come out from this point is high. We had learned that if we increase the height, the pressure will increase. So for these 2 points, the height of the water in the column is this much. For CD, if we can check the point CD, the height of water which create pressure on this point will be this much, which is lesser than EF. And at point AB, the height of water which is creating pressure is this much only. So here the height is decreasing when we go upwards. So the pressure is also decreasing. Here is the maximum pressure, so water is going far away from the hole. Here the pressure is lesser than the earlier one, and here the pressure is very low. Okay, so this is one of the applications which we use in this chapter, and which is also be asked in several questions. Okay, so I hope you have understood today's class. So we are taking up the next class. We will continue this topic, and in the next class we will take up atmospheric pressure. So till then you just derive the formula for pressure and do the numericals for this topic. Okay, thank you.